let's get started. So basically the course in general was divided by two parts. The first part I'm going to show some of our interest in, from our center to compare different detection tool and see just it's kind of performance comparison, use the same standard benchmark data, and that's why we get interested, because we want to get into get a sense how the tool perform in terms of same kind of data. And then the next part I'm going to more on detail of each individual tool we choose to comparison. Just give a sense how the tool runs. Particularly, we probably focus on one or two of the tools. So just give a sense practically how do you use that. So and some little tips we run into through the process of testing. So that's basically the plan for today. So first of all, I want to just of course. Keep already introduce myself. I just give a little bit deep on that. So about my background. So currently I'm a manager of the functional genomic group at ABCC. And then I have a hands-on experience in bioinformatics and particularly data analysis and tool development for both sides for more than 11 years. And I have a web lab experience with my PhD in molecular biology. And also I have my expertise mainly on data analysis and integration. That's our interest now. So, and system biology focus on microarray and next generation sequence or NGS data in recent years, and other high throughput data like proteomic, metabolome, stuff like that. And primarily, I also working on some analysis too. I have a tool primarily on the pathway analysis, like WPS, SNP, and PPEP. If you're interested, you can ask me. So anyway, and recently interested in NGS-based SNP detection tool, evaluation and comparison, and SNP impact assessment and integrative pathway analysis. So for NGS data analysis, it's very common in the field that we have three stages of the data analysis. It's called primary data analysis, secondary data analysis, and tertiary data analysis. And each has a specific function for that. And no matter what platform you have, either RNA-seq, exon-seq, or chip-seq, you can you always run through this first stage like instrument specific. So it's usually application dependent. It's provided by the manufacturer of the tool. So usually you don't have to worry about it. Just follow the instruction and run through that. You get a sequence and quality volume for that. So just depend on which platform you use. And then we, as a bioinformatician, you mainly focus on the secondary data analysis or tertiary data analysis. Particularly for secondary data analysis, application specific. If you're doing RNA-seq, you want to do some like whole transcriptome analysis, sort of. You get reads, your the FKPM, or all kinds of like read from quantitative results, just like a microarray, and then you start to use a lemma or whatever to do the analysis, something like that. Then for exon-seq, you do a variant detection. So that's where we're focused today. For tertiary data analysis, it's more on experimental side because it depends on what the investigator what's the question they want to address. So you can do genetic analysis for exon after the SNP call, or you can do differential expression for RNA-seq. And then you can do binding site assessment, with this chip-seq thing. So there are all kinds of things you can do. Most importantly, which I mainly interested in, I think everybody interested in the field, is how do you put things together in the context of biological context, pathway, network, stuff like that, and how do you put the data together for different aspects, from different platforms.